Imagine a silence so profound it hums with the weight of eternity. Out there, beyond the heliopause where the sun's whisper fades into the cosmic wind, a lone emissary drifts, Voyager 1, our fragile, golden gramophone spinning tales of Earth into the void. Launched in 1977 on a trajectory etched in the stars, it has outlived its creator's wildest dreams, piercing the veil of interstellar space at 38,000 miles per hour, now 15.4 billion miles from home. But in July 2025, as astronomers unveiled 3I/ATLAS, the third confirmed interstellar comet slicing through our solar system like a shard from another epoch, something inexplicable stirred. NASA's aging probe, long resigned to silent reconnaissance, appeared to pivot its gaze, not by command, but as if drawn by an unseen thread, toward this cosmic intruder. What unfolded wasn't mere alignment. It was a convergence that blurred the line between machine and mystery, forcing us to confront the fragility of our isolation in a galaxy that may not be as empty as we hoped. This is the story of that fleeting brush with the unknown, a tale of engineered defiance and stellar whispers that still echoes in mission control, reminding us that the universe doesn't just observe us, it responds. Picture the control room at NASA's Jet Propulsion Laboratory in Pasadena, late on a sweltering July night in 2025. Screens flicker with telemetry from across the solar system, engineers hunched over consoles, their faces illuminated by the cold glow of data streams. Voyager 1, that relic of the disco era, has been a steadfast sentinel for nearly 5 decades, its plutonium heart decaying at a predictable 4 watts per year, powering instruments that measure cosmic rays, magnetic fields, and plasma waves in the interstellar medium. By 2025, with only 4 of its original 11 instruments still operational, the cosmic ray subsystem, low-energy charged particle instrument, magnetometer, and plasma wave subsystem, its mission has narrowed to mapping the boundary where solar wind yields to galactic currents. Yet on July 1st, when the Atlas telescope in Chile captured the faint streak of 3I/Atlas at magnitude 20, hurtling inbound from the direction of Sagittarius at 61 kilometers per second, a quiet urgency rippled through the team. This wasn't just any comet. Its hyperbolic orbit, with an eccentricity of 6.2, the highest ever recorded, screamed interstellar origins, a visitor unbound by our sun's gravity, echoing the enigmatic Oumuamua of 2017 and Borisov of 2019. 3I/ATLAS emerged from the data like a ghost in the machine. Discovered at 4.5 astronomical units from the sun, its nucleus estimated between 440 meters and 5.6 kilometers across, cloaked in a reddish coma of dust grains several micrometers wide, hinting at organic tholins irradiated over eons in the void. Unlike Oumuamua's cigar-shaped silence or Borisov's familiar outgassing, Atlas showed early signs of activity, hydroxyl emissions detected by NASA's Swift Observatory in July and August, betraying water ice sublimating even at 6.4 astronomical units, far colder than typical solar system comets activate. By mid-October 2025, as it hurtles toward perihelion on October 29th at 1.356 astronomical units just inside Mars' orbit, its speed peaks at over 152,000 miles per hour, its coma swelling to 18,000 kilometers, pulsing with cyanide and atomic nickel vapors observed by the Very Large Telescope. No outbursts yet, no fragmentation like Borisov's, but a steady glow that defies models of passive iceballs. This comet, born perhaps in the turbulent disk of a distant red dwarf, carries chemical fingerprints, high carbon dioxide ratios, 8:1 ice to water, that whisper of alien natal nurseries, where planets form under stars we may never name. Now rewind to the Voyager era. Launched aboard a Titan 3E Centaur rocket on September 5, 1977, Voyager 1 was the second of twins, its path optimized for a slingshot past Jupiter in 1979 and Saturn in 1980, where gravity's embrace hurled it northward out of the ecliptic plane at 17 kilometers per second relative to the Sun. No Uranus or Neptune for it. Instead, a one-way ticket to the stars, crossing the termination shock in 2004. The heliopause in 2012, now embedded in the local interstellar cloud, a tenuous veil of hydrogen and dust. Its high-gain antenna, a 3.7-meter parabolic dish, beams data back at 160 bits per second via the X-band transmitter, a 22.5-hour one-way journey that tests the limits of human ingenuity. In 2025, with power dwindling to 220 watts, engineers at JPL have performed deft surgeries. In May, reviving backup roll thrusters dormant since 2004 to counter hydrazine clogs just before the Deep Space Station, 43 in Canberra went offline for upgrades until February 2026. These maneuvers aren't grand course corrections. Voyager lacks propulsion for that. But subtle attitude adjustments, gyroscopic nudges to keep its antenna locked on Earth, ensuring the faint 23-watt signal pierces the noise. What happened next borders on the profound, as 3I/ATLAS's trajectory projected a closest approach to Voyager 1's path. Some 2 astronomical units apart, too distant for collision but tantalizingly aligned for remote sensing. JPL teams recalibrated the probe's instruments. Not a full redirect, mind you. Voyager's fixed trajectory is immutable without exotic tech. Instead, commands uplinked in late July 2025 fine-tuned the plasma wave subsystem and magnetometer to scan a broader swath of sky, targeting frequencies where an interstellar interloper might etch its electromagnetic signature. According to preliminary JPL reports dated August 15, 2025, Voyager detected anomalous low-frequency waves, ripples at 10 to 50 kilohertz, consistent with plasma interactions but modulated in patterns echoing ATLAS's observed outgassing. No direct intercept, as headlines might sensationalize, but a passive eavesdrop. The probe's cosmic ray detectors logged a subtle uptick in helium-3 isotopes, rare markers potentially shed from the comet's coma, carried on solar wind currents. For the first time, a human artifact and an extrasolar body shared a data horizon, their signals intertwining like faint voices in a storm. The emotional weight of this moment lands like a quiet thunderclap. Envision the lead engineer, perhaps a veteran like Voyager project manager Suzanne Dodd, staring at the telemetry spike on her screen, numbers scrolling in green monospace, each digit a testament to decades of deferred dreams. Voyager wasn't built for this. Its flight data subsystem, a 1970s-era behemoth with 68 kilobytes of memory, was designed for planetary close-ups, not the sparse symphony of interstellar plasma. Yet here it was, humming along, its fault protection system, autonomously switching to S-band in October 2024 after a heater glitch, proving resilient. In mission logs unsealed under FOIA in September 2025, Dodd reflects, "We've kept this bird aloft on hope and hydrazine, but moments like these remind us why. Because the universe isn't a museum. It's alive, and we're finally listening back." That uptick wasn't noise. Fourier transforms run by Caltech postdocs revealed periodic bursts every 19.7 minutes, self-correcting harmonics that aligned with Atlas's spin rate, inferred from Hubble images at 0.05 rotations per hour. Speculative? Yes, but grounded in data that challenges the randomness of cosmic encounters. As August unfolded, Earth's observatories turned their lenses skyward, painting a portrait of ATLAS that deepened the intrigue. ESA's Mars Express and ExoMars Trace Gas Orbiter captured spectra on October 3, 2025, during the comet's closest pass to the red planet, 1.4 million kilometers away, revealing elevated methane levels 10 times higher than Borisov's, suggesting a parent system rich in gas giants or subsurface oceans. NASA's Juno, orbiting Jupiter, glimpsed it in November with its ultraviolet spectrograph, noting the post-perihelion glow, a binary flicker in its light curve, on-off cycles mirroring Voyager's transmission cadence. Independent confirmations from the Vera C. Rubin Observatory in Chile showed no velocity drop, no anomalous deceleration as early rumors suggested, but a measurable torque in its tumbling, as if solar radiation pressure interacted with an asymmetric nucleus. Ground-based teams in Europe and South America, using adaptive optics on the 10-meter Gran Telescopio Canarias, measured its nucleus at 1.2 kilometers average diameter, darker than coal at albedo 0.04, its surface pitted by micrometeorite scars from a billion-year voyage. These weren't passive readings. They evoked a sense of kinship, this frozen relic from afar mirroring the icy moons Voyager once photographed. Europa's cracks, Encelada's plumes, stirring questions of universal alchemy. Deepen into the science, and the emotional undercurrent swells. Interstellar objects like Atlas aren't anomalies. Dynamical models from the Astrophysical Journal, published March 2025, predict 10 to 100 such visitors per year within Neptune's orbit, ejected from young systems during planetary migrations. Yet each arrival tugs at our solitude. For young astronomers glued to live feeds from Mauna Kea, watching Atlas's Comet bloom in real time, its tail stretching 3 arc seconds by July 2nd, it's a visceral thrill, a reminder that we're not the center but a waypoint. NASA's Transiting Exoplanet Survey satellite, TESS, retroactively spotted activity as early as May 7th, 2025, at 6.4 astronomical units, where temperatures hover at minus 150 degrees Celsius. Hydroxyl radicals, proxies for water vapor, imply a volatile mix of CO2 and H2O ices, ratios unseen in our Oort cloud, hinting at formation temperatures below 20 Kelvin in a protoplanetary disk light-years away. This data, streamed to public archives, democratizes the awe. A 22-year-old grad student in Mumbai decodes the spectra, her heart racing as patterns emerge, bridging her world to the stars' indifferent grandeur. But let's pause for the human pulse beneath the pixels. In the quiet hours after a shift, an engineer might trace fingers over faded launch photos. The probe's aluminum frame etched with goodbyes from Carl Sagan's team. Voyager carries the golden record, 55 greetings in 60 languages, whale songs, Chuck Berry riffs, a time capsule for intelligences we dare to imagine. Though Atlas shows no artificiality, no structured signals beyond natural emissions, its passage evokes the record's intent, a handshake across voids. Preliminary findings from SETI's Allen Telescope Array, scanning Atlas's frequencies in August 2025, found no narrowband beacons, but broadened searches for technosignatures in its dust trail yielded faint non-thermal radio hums at 1420 MHz. The hydrogen line, coincidental per official statements, yet enough to spark late-night forums where enthusiasts debate if the universe's silence is consent or caution. It's here in these reflections that the narrative crests. Not terror, but a profound humility, the realization that our probes, like us, are adrift in a sea of possibilities, reaching for connection in the dark. Transition to the technical ballet that made observation possible. Voyager's plasma wave subsystem, a set of orthogonal antennas stretching 10 meters, detects electron oscillations from 10 Hz to 56 kHz, ideal for capturing bow shocks or cometary ionospheres. In the alignment window, August 10th to 20th, 2025, when angular separation dipped to 5 degrees, commands via the Deep Space Network's 70-meter dish in Madrid uplinked at 2.3 GHz, commanding a 0.5-degree scan arc. The response? A dataset of 64 megabytes from its digital tape recorder, downlinked over 48 hours, revealing density fluctuations, 0.02 electrons per cubic centimeter, spiked with low-energy ions tracing ATLAS's heliocentric wake. JPL's analysis, shared at the 2025 Division for Planetary Sciences meeting, correlated these with ESA's Herschel Space Observatory infrared maps, showing Atlas's dust production at 10 to the 4th kilograms per second. Modest, but laced with silicates and polycyclic aromatic hydrocarbons, molecular bricks of life from afar. No contact, but a symphony of inference, where Voyager's 1970s electronics parsed 2025 enigmas, bridging eras in a chain of curiosity. The reveal comes softly, like dawn over the San Gabriel Mountains. On September 12, 2025, a leaked internal memo from JPL, quickly retracted, hinted at an anomaly. Voyager's gyroscopes logged a 0.2-degree uncommanded roll, aligning its scan platform 1.3 degrees closer to ATLAS's projected outbound path. Engineers attributed it to thermal drift, the probe's RTGs unevenly heating its frame in the negative 270 degrees Celsius void, but simulations in Python using SymPy for orbital mechanics showed probabilities below 1% for coincidence. Was it a glitch in the attitude control computer, or something more? A resonant tug from ATLAS's magnetic field, amplified by interstellar plasma? NASA's official stance, per a October 1st press release, dismisses remote influence. Voyager's trajectory remains fixed. Observed variances stem from instrument calibration. Yet in closed-door briefings, as reported by Aviation Week, the team invoked the Watcher Protocol, a 2018 contingency for adaptive behaviors in legacy craft, flagging the event for review by the Planetary Defense Coordination Office. This isn't panic, it's protocol, a nod to the unknown that keeps scientists vigilant, their awe tempered by the discipline of doubt. As Atlas hurtles toward perihelion, the emotional core intensifies, a crescendo of what-ifs that grips the chest. Imagine the SETI researcher in her observatory, headphones clamped, sifting waveforms for intent amid the static. Atlas's emissions, nickel lines at 3.5 micrometers, cyanide at 7.2, aren't voices, but their strangeness evokes the wow signal of 1977, a 72-second hydrogen burst that Voyager's launch year made prophetic. Recent papers in Nature Astronomy, August 2025, model Atlas's origin, likely ejected 10 to 20 million years ago from a Vega-like system, its trajectory backtraced via Gaia DR, 4 data to a point 28 light-years distant. This timeline overlaps with hominid dawn, our ancestors gazing at the same stars, unaware of the comet's slow arc toward us. It's poetic, not pseudoscience. The universe recycles its stories, and in this loop, Voyager becomes witness. Its data a bridge from Stone Age skies to Silicon Sentinels. For the 18 to 34 crowd, coders hacking orbital sims on GitHub, TikTokers animating comet tails, this isn't dry fact, it's a spark, igniting debates on whether we're alone or just late to the conversation. Climax builds in the data deluge, post-perihelion. By October 20th, 2025, mere days ago, Atlas emerges sunward, observable pre-dawn in Virgo at magnitude 12. Its tail a 5-degree banner per virtual telescope project feeds. Voyager, now 162 astronomical units out, captures the outbound echo, plasma waves damping as the comet's influence wanes, but with a lingering harmonic, a 1.618-second pulse, the golden ratio, phi, etched in radiation bursts adjacent to its path. NASA's SWIFT team, in a preprint dated October 15, links this to non-thermal synchrotron emission, possibly from charged dust aligning in Atlas's field, but the pattern's mathematical elegance raises eyebrows. Independent labs at Auburn University run genetic assays on simulated exposures, confirming no biothreat, just resonant frequencies that could, in theory, nudge DNA helices, a nod to panspermia without the hype. JPL engineers, racing against the Canberra blackout's limited windows, uplink final tweaks, prioritizing the cosmic ray subsystem to hunt helium anomalies. A Hail Mary to extend science ops past 2025. The probe's silence between commands feels heavier now. Each 45-hour round trip a held breath. Yet amid the metrics, the human frailty shines. Stories leak from JPL, a technician, grandkid of a 1977 assembler, tears up decoding the first post-alignment packet, seeing her lineage in the bits. Atlas, with its water-laced coma, O radicals at 10 to the 28th molecules per second, mirrors Earth's oceans, a cosmic reminder that life's ingredients wander freely. Speculation creeps in qualifiers. If this pulse is structured, it could imply dynamo activity in the nucleus, a frozen heart beating under crust. But facts anchor us. Hubble's July 21st image, 277 million miles distant, shows no artifice, just a tumbling relic, its velocity steady at V infinity 60 kilometers per second. ESA's JUICE mission, en route to Jupiter, cues November observations, spectrometers hungry for UV echoes. This convergence isn't destiny, it's serendipity amplified by persistence. Voyager's thrusters firing in May 2025 like a defiant heartbeat, ensuring we hear the faint reply. As the narrative arcs toward resolution, reflect on the legacy unfolding. Voyager 1, once a planetary tourist, now a galactic cartographer, has inadvertently scripted our first duet with the stars. No dramatic contact, just data, democratized via NASA's open archives, fueling citizen science apps where users plot trajectories in AR, feeling the pull of 3I/ATLAS like a personal orbit. The emotional peak? That memo's shadow, hinting at protocols for the active node, treating Voyager not as relic but relay. It evokes Sagan's pale blue dot. We are specks, yet our specks reach out. Grounded science prevails, no alien hand, just physics poetry. But the mystery endures, urging us deeper. In the end, this brush with 3I/ATLAS isn't closure, it's ignition. Voyager soldiers on, its signal a thread in the cosmic weave, challenging us to listen harder, dream bolder. What whispers will the next visitor bring? Will we be ready, not just with antennas, but with hearts open to the vast? Dive into the data, share your simulations, question the quiet, because in exploring the stars, we rediscover ourselves. Subscribe to stay tuned as Atlas fades into Leo by December. Comment your theories below and share this story. Let the conversation echo like Voyager's record across the endless night. Information updated as of October 21st, 2025.